Hello everybody, I'm Shreya Mishra and today I'm going to be solving the third question of Shastra Coding Challenge Contest A, which was held on the 28th of July, called Unique Manifold. So let's look at the question first. So here you have a manifold of integer containing n elements. So it's basically an array containing l elements or n integers, and your goal is to make this array a unique array, which is basically where every element of the array is different from the other. But the only operation you can do on any of the elements to convert it into a unique array is increase the element by 1. So you need to find the minimum number of steps or the minimum number of times you will do a +1 operation on any of the elements before the array becomes a unique array. And all you have to print is the number of steps it took to convert to make it a unique array. If we see the sample input, we have to take the input of the number of test cases, which is how many arrays are you taking from the user to perform this test on, the length of the array and the elements of the array. And all you have to give as an output is how many steps it would take to convert this array into a unique array by only performing +1 operations on the elements. So for this, the first thing you need to do is create a variable, such as like I have done, create a variable count, which will keep track of how many times are you performing the +1 operations on any of the element. Now, for example, if the user gives you an array which is already unique, like this, then the count would be 0 and you will have to print 0, which would mean that the array is already unique. So if you look at the code here, I have taken first of all an integer t from the user as a standard input, and I have created a for loop which runs from 0 to t. So whatever test this is, it will the same test will be applied for all the 3 test cases, and it will run t number of times. Then I've taken int n, which is the number of elements in the array, and then I've created a for loop from 0 to n, which will allow the user to input the elements of the array. Now we have to see in what cases can the count be 0, which the first is either the length of the array is 1. So if there's only one element in the array, it would obviously already be unique. Then you would have to print 0. Or you can test if the whole array is distinct. If the arrays, each element of the array is distinct, then also you would print 0. Now in the case that the array is not distinct, I have created a function which is called over here, which where you would actually have to make changes to the array and make it a unique array. So for this, let's look at the approach first. Suppose you have an array which is not distinct, like 4, 3, 5, 4. So here, as you can see, there are 2 4s, so this array is not unique. So to make it unique, the first step would be to sort the array so that all the common numbers can come together. So if I sort this array, it would be 3, 4, 4, 5. Now that I have sorted this array, I would start from the second element or the element at the first index and compare each element to the previous element and see if it's equal to it. So if you see 4 is not equal to 3, so then you don't have to make any change. But here 4 is equal to 4, so we can perform a +1 operation over here, since that's the only operation you are allowed to perform. So this will become 3, 4, 5, 5, and the count will be incremented by 1 because we performed the operation one time. And then you would look at the last element and compare it to the previous element, which is again the same. So then you would have to perform the increment operation one more time and make it 3, 4, 5, 6, and the count would be 2. So now this array is unique, and what we have to print is the number of steps we needed to make this array unique. So here we will print the number 2. Now let's look at another test case when there are more than 2 common elements. For example, 4, 4, 4, 4. So over here we will again start from the second element and compare it to the previous one. So now we will have 4 5 4 4, but and the count will become 1 again. But now the catch here is when you look at the third element and you compare it to the previous element, it's not equal, but it is equal to the first element. But we were only comparing the current element to the previous one. So what we can do here is, as you remember, we had sorted the array at the start. So ideally each element should be greater than the previous element. So since this is not greater than the previous element, we can not only check for equal to, but also if the element is smaller than the previous element. So if the element is smaller than or equal to the previous element, then we make a change. So over here, how many plus ones would you need to add to make this 4 distinct? So what we would do here is look at the difference between the previous element and this element, which is 1, like 5 minus 4 is 1, and then you would need to add you need to add 1 plus 1 to make it equal to the previous element, and then you'll need to add another plus 1 to make it distinct than the previous element. So here you can do 2 plus 1 operations and increase the count by 2. So here you will have 4 5 6 4, and the count would increase by 2 because you did 2 plus 1 operations. So the count becomes 3. When you go to the last number again, you check the difference between, you see that this is less than the previous number, so you do need to make a change here. And you see the difference between the last number and this number. So 6 minus 4 is 2. So it would require 2 steps to make it equal to the previous number, and another step to make it distinct to the previous number. So here you would have to perform 3 plus 1 increments. So the array would finally become 4 5 6 7, and the count increases by 3. So the count will become 6, and over here we will have to print 6. So we needed to perform 6 increments or 6 plus 1s to make this array unique. Now let's see the code for this. As we saw here, if the count is not 0, then I made a function and called it over here. So the function, first we will start by initializing the count as 0, then we sort the array, which, as we saw, why it is necessary first to bring all the common elements together, and then also so that we can check for both equal to and less than sign. So we start from the element at the first index, because the element at the 0th index does not have anything to compare to, and then we run the for loop till the end of the array. Now if the present element is less than or equal to the element before it, then count will be count plus the difference between both the elements plus 1. As we saw here, if you can see, like we had 4 5 4 4, so this was 5 minus 4, which is 1, which you need to make it equal to the previous number, and then another plus 1 to make it unique. So the difference between both the numbers and plus 1. So this will be the update we make to count, and then we will change the present number with the previous number plus 1, and then this function, we perform this function for each element of the array, and once the for loop is complete, we will get the final number of count, or the minimum number of steps that we took to make this array unique. So the count was basically how many plus 1 operations do you need. So we return this count and it will print here, and you would get the output as whatever the value of count is at the end. So let's try to submit this code. And as you can see, all test cases are accepted. So I hope that helped you, and thank you for watching. The source code for this question will be available in C, C++, and Python in the description box below. If you found this video helpful, please like and subscribe, and also follow ft.Shastra on Instagram and LinkedIn. Thank you so much for watching.